Hi, now we're going to try to relate the concept of grams to moles so we can get an idea of how many atoms we'd be weighing out if we went to our scale and weighed out a specific number of grams of a substance. And what we'll do is we'll look at carbon as an example here. So if we look at the relationship between grams and moles, if we look at carbon from the periodic table, here's what you might see. If you pull out your periodic table, you'll see that we have the element symbol for carbon is C. Its atomic number is 6, which tells us it has 6 protons. Then we have this weight listed underneath, which is again the average of all the isotopes of carbon. So if we took all the carbon 12 atoms in the world and all the carbon 13 and 14 and added up the number or percentage of each and multiplied those by their weights, this would be the average weight of a carbon atom. Right? It wouldn't represent any specific isotope, but it'd be the average of all the carbon atoms in the world. And this weight is how much one atom of carbon weighs. It's 12.011 AMU per average carbon atom. But this weight also tells us how much one mole of carbon weighs. So if we had 12.001 grams of carbon, we'd have a mole of carbon. So remember that 1 mole of carbon equals 12.011 grams of carbon. All right, so this would be the same for any other element that we could pick on the periodic table. 1 mole of hydrogen would weigh about 1.01 grams. So this number underneath this atomic weight is also the mass of 1 mole of whatever element we're looking at. So we can find all of that from the periodic table. And so 1 mole of carbon also equals 6.022 times 10 to the 23 atoms of carbon. And if we look at these are equivalent statements, right? So these could also be set up as conversion factors. So the way we would use this information from the periodic table is we say how many atoms are in 15 grams of carbon. Well, we're starting with grams of carbon, so that would go on top on our equation. So if we have 15 grams of carbon, what we need is a way to convert the number of grams of carbon to moles of carbon. Right, and we know that 1 mole of carbon weighs 12.001 grams, so we want to know the relationship between 1 mole of carbon and its mass, and 1 mole of carbon weighs 12.011 grams. So now we have grams of carbon disappearing and we're at moles of carbon, but we want to go to atoms of carbon, so we want to know the relationship between, didn't leave enough space, this is going to be a long number, atoms of carbon and moles of carbon, right? And so we know from this that 1 mole of carbon contains 6.022 times 10 to the 23 atoms of carbon. So then we can say that there are 6.022 times 10 to the 23 atoms of carbon in every mole of carbon. And so we can determine how many atoms of carbon are in 15 grams of carbon by doing this multiplication. So we multiply everything on top and divide it by everything on the bottom, and you should get 7.5 times 10 to the 23 atoms of carbon. Right. And so we'll be using these numbers from the periodic table moving forward in a lot of calculations. So it's important that we understand that this number, this atomic weight, tells us the mass of 1 mole of carbon, right? And so that's our equivalence there, and then we know that every mole of whatever we're talking about contains 6.022 times 10 to the 23 units of whatever we're talking about.